authenticate or authorize, all you want is all my data on wire should be encrypted. Then SSL is the only thing that you need to do, and Kafka will allow you to just do SSL. SASL is the API for authentication that Kafka has chosen for the default implementation. So with SASL, we provide an implementation backed by Kerberos where you can authenticate and you can say who is the user that is connecting to Kafka server. So the first problem is, can you encrypt my data on wire? SSL addresses that. The second problem is, who are you and who is the server that I'm connecting to? SASL addresses that. And the third one is, okay, I know who you are. Now I want to figure out what can you do? What are you allowed to do and what are you not allowed to do, which is the authorizer part. So we'll cover all three today. So SSL in Kafka security layer. So the way Kafka brokers work as of now, it basically opens a TCP port and then it uses Java's NIO selectors. I don't know if everybody's familiar with that, but it's basically a non-blocking IO channel. So anytime there is actually data incoming, data outgoing, new connections coming in, that's when the selector gets invoked and the selector will do actual work. Otherwise, it's just sitting there, not consuming any resources. So for SSL, what we had to do is we want to do encryption over this already available TCP socket layer. The way this was achieved was, sorry, I forgot that I shouldn't step out. So the connections, one thing I forgot to mention, the connections are long living, meaning once you connect to a Kafka broker, you are connected unless TCP breaks it or you say I want to close the connection. So if you authenticate once, that's done. We are not going to authenticate you every single time you make a request. The authentication happens only once. Okay, so now this is just a diagram explaining what I said. So there is a selector which has a select method, and when no datagram is ready, it just says, okay, I'm just going to wait here. I'm not going to do anything. When there is packets available, data available, it will say receive from this packet. Or when there is something that is ready to write, it will say send to. Both are just APIs at Java level. If you have questions at any time, just let me know. Now the challenge with SSL and SASL implementation was Kafka kind of has this agreement with the users that between a version to the next version, they will not break any backward compatibility. So we had to implement the new features, SSL and SASL, without breaking the binary protocol, which meant that there has to be a way so that we can, so Kafka has length encoded protocols, meaning they don't use any existing encoding scheme. They write something at the beginning of a packet, they'll say, here is what the packet length is, and here is the type of the packet. And then they have their own serialization, deserialization mechanism, which kind of helps them in tuning the performance that you generally see with Kafka. So we wanted to keep that as is, and we want to make sure that before sending and receiving any request, client has to authenticate if authentication is configured. So what we did is, instead of using the existing socket channel, which is Java providing, we kind of made an extension of it, which is Kafka channels. So Kafka channel is nothing but an extension of socket channel with SSL and SASL support, both pluggable. So now we are talking about two layers. So the transport layer, which is how data gets transmitted, that is a pluggable layer, and there we have implemented a SSL-based transport layer, which will allow you to do wire encryption, and we have a plain text-based transport layer, meaning your text is not encrypted at all. The authenticator, which is the who are you question, for that there is also a pluggable interface, and you can plug in whatever other authenticator you like. If you like Kerberos SASL, you just use the default one that we have. If you are an AWS user and you want to use IAM to authenticate, you write your own. But the point here is, it's pluggable. You can put it in whatever else you want to put in. So now let's go over the SSL handshake. So the transport layer first gets initiated and it does its handshake. If it's plain text, it's very simple. If it's SSL, there are multiple steps involved, and we'll basically look at it. Once the handshake is complete, that's when authenticator initiates the SASL protocol, which is the protocol that you would use to establish identities for each user that is connecting to the broker. So how does SSL work? During SSL, you are basically signing some random secrets and exchanging that. For that, your Kafka server must have, in case of, because Kafka runs in JVM, you must have a key store and a trust store. Key store is where you have your own signatures with which you sign your packets. Trust store is where you have things that you trust. So Kafka server must be configured to have those three things with right certificates. And Kafka's clients needs to have Kafka server certificate to say that I trust this server certificate. Only then they can actually connect over SSL channel. So once you have these two configured, and there is like a huge blog post, if you Google Kafka security, there is a big page describing how to do SSL, how to generate certs, how to add them to key store, how to add them to trust store, and we'll not go over that right now. The Kafka channel, again, as I think I kind of already went over this, it's basically an extension, and it does what the socket channel does, and on top of that, it kind of does things so that we can do SSL and SASL in a pluggable manner. Okay, so the SSL transport layer, which is the transport layer implementation, which does SSL over using Java's SSL engine protocol. So Java provides this SSL engine class, which allows you to use Java's key store, Java's trust store to exchange your secrets and verify that this encryption and decryption happens correctly. So in case of Kafka's SSL, we use SSL engine from Java. Again, because it's a pluggable layer, if you are not happy with it, if you think there is a vulnerability, if you have your own, you're free to choose whatever else you want to choose. And this is something that I wouldn't have put here, but this is Harsha's slide. But so what this is showing is how the SSL handshake happens. Client sends hello, server sends hello, then server sends a certificate, client verifies that, oh, I have this certificate in my trust store, can I establish that this encryption is actually going to work moving forward. There is also optional steps so that you can use client-side certificates to authenticate as well. I would say unless you have something against KDC, don't do that. Just go with KDC because it's much better identity establishment. Again, these are internal details. Let's try not to go over that. So principal builder, this is another pluggable layer which allows you to construct what your user looks like. So if you are a Kerberos user, you know that your identities will look like user at realm or sometimes user/host at realm, which may not be the thing that you want. Maybe you just want a, every time just extract the user part and say anybody who has this user in their key tab. Everybody here familiar with Kerberos and KDC and key tabs, or I'm not making sense? Yes, no? Okay, so let me go over just the basics of it, right? So Kerberos has this server called KDC, which is like a centralized repository where all the secrets are stored. Anytime you want to say, I want to add a user, like you would go to that server and say, add this user to your database. At the same time, you can say, I want to generate a key tab file which will be associated with this user. So think of key tab as just a file which, when accessed and presented to the KDC, it would know that, yes, I can verify that this is actually coming from this user. It's like a secret that is generated just for you. So key tab, once you have that file, on most Linux programs, you have this program called kinit, using which you can say, kinit, here is my key tab, and this key tab is for this user, which is, let's say, parth@netflix.com. It'll go contact KDC, they'll run some internal protocol, and finally, KDC would either say, yes, this key tab is verified, here is a ticket, here is a TGT, which is another, basically something which will tell them that, okay, here is a ticket granting ticket, which is, you can now take this secret, go to any other service that is running, and that service will be able to verify that, yes, you are the user that you say you are. So KDC is basically a centralized authority which can give you some secrets that you can share with other services and then connect to them and verify your identity. So when I say key tab, it's just a file in which you use to establish identity with KDC. Okay, so In case of SSL, you have X509 certificates, and that's how you can establish identity if you want to establish identity in the client from the client point of view. On server side, you need to, because you're not just using this for identity establishment. You are also using the secret and parts of the secret for encryption. So that's what the Kafka Security SSL, the principal builder, allows you to do. Because if you look at an X509 certificate, it will look like AA:BB:, a random string which will make absolutely no sense. If you have your own principal builder, you could take that complete random string and make something meaningful out of it and return that, so that in your debug logs, in your, when your user's being authenticated, you can actually print something useful. Or you can have whatever else processing pipeline which is processing these logs make some sense, which is why principal builder being pluggable allows you to do multiple things. Now, what was the performance impact if you enable SSL? The throughput was decreased by 20%. The latency was increased by 30%. And there is a Jira, and there are some bugs that we introduced as part of this. There was one where, so Kafka does this thing called send packet directly, meaning, so I don't know if you guys know, there is a performance benefit in Kafka where when you are writing from your OS level, or rather your system user space to OS space, and you want to write it down to network, there is a OS level or Unix level function called send file, which will allow you to go from user space to OS space to network directly, rather than going from user space to OS space to user space and then to network. So you basically skip one entire system call subtree, which gives Kafka enormous advantage in terms of throughput and latency both. Because of SSL, we were not able to implement send file functionality as is, and that resulted in some bugs, and then they resolved it, and then things look much better. But this is the numbers after that, I believe. Even after send file was fixed, we actually got decrease in throughput by 20%, increase in latency by 30%. But when you're doing encryption, that is kind of the penalty that you have to pay. This list, if you don't care about how things actually work and just want your cluster to have SSL, this is the only slide you should read. What it's doing is, it's telling you on broker side, I want a listener. So in Kafka's case, now you can have multiple ports open, and each port can say, I can support SSL. The other port can say, I can support plain text in a single server. So here what you are saying is, the protocol type that my listener is going to support is SSL, the host name, : on what port are they actually going to have SSL. And this is like a comma separated list. So you can then have plain text : and some other port, and that port will support plain text if you want to run in that mode where you have multiple options. The key store location, password, I think rest of it is very self-explanatory. So if you just configure these things should just start working for you. And there is a huge blog post, as I said. SASL, Kerberos. Okay, so SASL is just an RFC written by someone, I don't know how many years ago. It's a way to establish identity between two entities. So SASL is a protocol, and Java provides an implementation with GSS API, which is what we used for implementing the SASL implementation. How many of you are familiar with JAS here? JAS, yeah, so JAS is Java's authentication and authorization system. What JAS allows you to do is use things like Kerberos to authenticate, and then it has its own authorization layer, which we don't use right now. But let's see, do I have a file here? Yeah, so I have a file. So when you are configuring your Kafka server and you want to say, hey, I want this server to have a way so that it can establish identities of the users that are connecting to it, you have to give a configuration that looks like this. What this configuration is saying is, and this is a JAS config, this is a standard JAS. If you go and Google's Java JAS, this is the standard that Java has put forward. In this config block, what you are specifying in first line is, I'm going to use a login module called KRB5 login module. So login module is an interface in Java. If you want to use Kerberos-based authentication, then you use KRB5 login module. That's a class that implements that. You are just configuring in that here. You are saying use a key tab. A key tab is a file, as we discussed before. Store key, meaning should I store this key internally or not? The service name that you are going to run as. When you start up your service, what is your principal service going to be like? And this is something that your client has to know in order to connect to you. The key tab that it's going to use to actually authenticate with KDC, this is the file that will be given to you by system administrators, or you will generate and put it on all Kafka brokers. And then the principal, which is the user as which, or the user as which the key tab was generated. The key tab is associated with a principal, as we discussed before. So once you have this JAS configuration and you specify there is a Java login config system property that you have to run with, and then it'll read that and it will authenticate and it will establish identity with KDC, and then every user that connects to it will also have to have the JAS configuration on its own side. It does non-blocking handshake so that to establish client-side identity, and then once any time a user connects to the Kafka server, it will have to present its own identity with a TGT, and then Kafka will be able to store that and say, okay, here is user one that just tried to connect to me, and the operations that they are doing that we will cover in authorization, how they are actually being authorized that only this operation is allowed for this certain user. The good advantage of having the authenticator and the transport layer being separate is now you can say, I want my transport layer to be plain text. I don't care about wire encryption, but I want to have authentication. So you can say plain text SASL, that's one way. Or you can say I want SSL SASL, or any combination of things that you have. If you have multiple authentication schemes and multiple transport layer schemes, you can mix and match in any way. Now, this is the SASL internal structure. This is the config that you pass. The JAS file that we just saw, that JAS file you have to pass here as Java security auth login config. And that's how Java knows, here is the file that I need to read in order to get the key tab information and the KDC information and all that. This is the wiki that I was talking about, how you can deploy SSL for Kafka. Now we'll move on to the authorization part. So this is the part where we are going to establish, if I trust that you are who you say you are, what are you allowed to do in my cluster? It's pluggable, again, just like anything else. If you don't like what we provide, you use your own authorizer. It's an ACL-based approach, just like any other authorization scheme. You define an ACL, which says you have access to this resource, you don't have access to this resource. So if you look at this slide, right, there are 5 pieces that comprises of the ACL. Principal, permission, operation, resource, and host. So a principal is a user, Alice. A permission is whether to allow or deny. Operation is read, write, create, delete, describe, list. Resource is whatever resource. In Kafka's case, it will be a topic name or a cluster or a consumer group. And then host, from which host are you allowed to do these operations? The principal basically is a principal type called a name. We provide user :name, so user Alice, user Parth. You can also support group. We don't do it right now. It's a PR that is pending review. You can add your own types if you want to, and if you just want to open it up to everyone, you just do user : star. Operations, here are all the operations that we support. So Kafka has let's say 20 APIs. We did not create an operation for each API. Instead, what we do is we map bunch of operations and map them to one single operation. We kind of do a classification approach, because that allows an existing ACL to work when we add new APIs, as long as it maps to one of the existing operations. So if tomorrow someone adds a new operation, I don't have to say everyone who's going to use this operation, I need to define a new ACL for you. If it's in the same class, the existing ACLs will work. The resource type, there are 3 right now: topic, cluster, and consumer group. Now that we have Kafka Streams and Kafka Connect, I imagine it may extend to more things in future. Just like user, if you have a wildcard, so then you can say resource type : store, meaning this user will have access to all resources, doesn't matter what type it is or what name it has. Allow and deny, these are the 2 permissions type. anyone who doesn't have an explicit allow. So if I did not say that user Alice has access to topic T, by default, when Alice tries to read or write from topic T, she's denied. So it's not like you have to explicitly deny everyone. You have to explicitly allow everyone. Now, then why do we have deny? The reason we decided that we will have deny is, let's say you are a system administrator and you have a finance department, and we didn't support group right now, and you want to allow everyone in finance department, but anyone outside of it, I don't want to support, right? Then how do you negate things? If you only have allow then and no deny, then you're going to say allow, 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 allow to everyone. In this case, you can just deny colon everyone else, but these guys. That is why deny becomes a very useful feature for system administrators who are trying to define ACLs. Deny takes precedence over allow ACLs, which is why it works. Host. So this, by default, you can say I want to allow user to connect and read from all the hosts. It doesn't matter what host they are connecting from. But there are financial industry companies where they have very compliance requirements to say only hosts from these particular region or these names can connect to your topics or read or write to your topic. And that's something that we wanted to support in the system rather than them going and configuring IP tables by themselves. So host, by default, you can take a star and it'll allow it from all hosts. But if you want to extend it to a specific host, that's something that we support. There are 4 configurations: an authorizer class, which defines what is the implementation that you want to use. The authorizer class is basically an implementation of one interface that we provide. We give you a default simple ACL authorizer, which relies on Zookeeper and stores all the ACLs in Zookeeper. You can use that if you like that. If you want to use something else, if you have your own ACL store, you can go ahead and use that. There are authorizer properties, which is only useful if you are writing your own custom authorizer. And default behavior for resource with no ACLs is, by default, as I said, it's deny everyone. You can specify, no, I don't want that. I want to say, by default, if I don't specify an ACL, allow everyone, because I'm just trying something, or I have topics that are open, you're rolling, upgrading something. These are the use cases where that config might come in handy. Yeah. Yes. Right. So when you define an ACL, as I said, there are 5 parts, right? Yeah. There is, let's go back a little bit. So you are saying Alice is allowed to read from topic orders, right? So when you're defining, you can again say operation equal to star, and you are allowing them everything. But if you define operation read, then only read is allowed. Okay, so yeah, so simple ACL authorizer, as we discussed, this is an out-of-box authorizer implementation. It stores all the ACL, whatever ACLs you add, they are stored in Zookeeper. It caches them because every request, unlike authentication, every request that you make has to be authorized. Meaning we'll have to go and say, does this user from this host trying to access this topic has this permission or not? So we can't go to Zookeeper because then Kafka will be slow as Zookeeper. So we want, to avoid that, we have our own cache implementation with a very good scheme so that your caches are invalidated pretty frequently, or every time you make a change rather. It also provides an authorizer audit log to say everything, and it's by default disabled. You can enable it, but then you have to realize every time you are coming in, you are actually writing to a log file, which will have its own performance impact. The CLI, which is, so Kafka allows you to kind of control all these ACLs. You don't have to only, it has a programmatic way to add these things, but you can also add these things using a CLI. You can add, remove, list ACLs, all using CLI. By default, generally what we have observed is all people want to do is, here is a user who should be allowed producer access, meaning he should be able to write to a topic and describe some topic. Here is a user who should be allowed as a consumer so that he can read from topics. So those things, we by default provide separate options for it. You don't have to go and define all the different permissions that are needed for that. There is Apache Ranger, and I think also Apache Sentry now. if you are hosting the solution, then they provide a nice UI. They already are integrated with Kafka, and you can search for your topic. It'll do auto completes, and you can drag and drop and all the fancy UI stuff. Ranger also provides auditing, which means that if you, and this is a much better auditing than what we provide. It doesn't just log, it actually goes and puts something in database in a batching format, and it creates a smaller batches so that there is no performance impact on your side, at least from the API level. So if you're using Ranger, that might be something that if you want auditing, Ranger might be a better solution for you. So this is after all this craziness, this is the current state of Kafka security. Because the problem is our Zookeeper clusters are unsecured. That's where Kafka stores its metadata. That is exactly, that's where you can go and just nuke everything and all your topics are deleted, and Kafka can't do anything about it. So we needed, the last piece in this whole pipeline is, let's secure Zookeeper so everything else is actually working. So now Zookeeper has its own SASL and MD5 protocol, or rather not protocol, but they have their own configuration nitty-gritty that you have to go through. In case of Kafka, what you have to do is, just like the JAS config that we saw for Kafka server, in that same file you have to add another section for Zookeeper, saying as a client, when Kafka servers connect to Zookeeper, here is the, so in JAS, I don't know if we have the JAS. Yes, we have the JAS. So basically in Kafka's server-side JAS, you will also put this section. And in this section, as you can see, the service name is Zookeeper, meaning the service I'm trying to connect to is Zookeeper. In the other case, it was Kafka because it was coming up as a service, and that service was Kafka itself. And here, if you see, the principle or the key tab is same, because that's the principle that is associated with the user who's running this service right now. Now, there is a KIP4, Kafka. So in Kafka, when you are trying to propose something, when you are making improvements, you have to file a KIP. So KIP4 is, right now, for as advanced as Kafka is, if you are trying to create a topic or delete a topic, it doesn't really go to a broker. You would imagine that they'll have a server-side API to do that, but they don't. When you make that call, all it does is it goes and creates an entry in Zookeeper. And then in background, Kafka's controller reads it and does things. So now, right now there is a KIP4 proposal which will make those APIs actually accessible. So create, delete, create topic, delete topic, all of that will become server side. The problem that this poses right now is, if I restrict Zookeeper to say only user Kafka can write to Kafka's directory, then that means anybody who's trying to create a topic earlier was able to do so because Zookeeper had no security. Now, unless you have Kafka server key tab, you can't create a topic. As soon as you go and try to write to Zookeeper, it will deny you because you are a different user and only Kafka user is allowed. So right now, if you enable Kafka security, the side effect of that is your users are no longer self-serve. They will have to come to you, or you'll have to distribute the Kafka key tab to everyone, at which point there is no security. So you will actually have to take requests from others if you are managing the Kafka cluster and create topics on their behalf. The group support, PR already available since 6 months, but nothing going on there. Pluggable auditor, that is something that we plan to do, but it's not yet done. I don't know if people know about delegation tokens, but that's something that is under discussion, probably will happen very soon. And then there is impersonation, which is also not on this slide. So impersonation is, if you, let's say you are running a, how many of you run a Storm or Flink or Spark streaming topology here, right? So in case of Storm, let's say you want to integrate Storm with a secure Kafka, or let's say Flink, right? You want to integrate with a secure Kafka. What you would have to do is, if you are running a 100-node cluster, every single node on that cluster now will have to have the key tab that your topology will use to connect to a secure Kafka cluster. That's a headache, and plus bigger problem is, if a server goes down, you replace it and you forgot to add that key tab there, then you're screwed. That worker will never actually be able to work. It will just keep failing. So generally, to address that problem, in Hadoop ecosystem, what people do is they have this concept of impersonation and delegation token. So in Storm there is Nimbus, in Flink there is some app master. What you do is when you, as a user, you submit a topology, or as a user when you submit your processing, the master will take that and say, okay, this user is asking me to go on his behalf and get the credentials from Kafka. So then the master user can go and say, for user A, I, the master, demand some delegation token. Once he gets that, it's that master's responsibility to distribute that token across the cluster, and everybody in that cluster now can use the token to authenticate rather than using a key tab or any other file. That's something that Kafka doesn't support yet. We are discussing it and we are trying to push it through, but it's not yet in there. So that's all coming. So in summary, these are the 4 things that we covered. Fire encryption, go for SSL if that's the only thing you care about. SASL if you care about who you are, but I don't think anybody will care about who you are without caring about what you can do. So if you are going to go through the authentication route, add authorization with it. And then make sure you secure your Zookeeper, because if you don't do that, everything else is pointless. And I think that's it. Yeah, so any questions? Maybe I think a lot of people didn't know what JARs or what the key tab structure is. Then it may not have made sense. And we can talk offline and I can describe in more details what those things are. Any questions?
One question I have is that now that Zookeeper is secure, before, assume we have a Zookeeper running, before we bring in a new Kafka broker, we should allow ACLs, enable ACL for that broker on the Zookeeper, right? To talk and to do or anything.
Right, so that depends. So what you are doing here is, if you see, you are doing principal Kafka/Kafka at withzen.com, right? That's your entire, your principal is user/host at some realm. In Zookeeper, there is functionality to say, when someone connects to it, just drop the host part and drop the realm part. I only care about the first user part. If you have that enabled, then in that case, as long as, because the way generally principals in Kerberos are created, it's user/host. So the user stays the same. It's always Kafka. It's just that now that there is a different broker, it will have its own host identity. Zookeeper would just drop it. It will not even look at it. It will just look at Kafka and say, yeah, you are allowed to do this. So you don't need to add new ACLs every single time, as long as you keep the username part same.
Actually, in our case, we are not using Kerberos. I am just using ACL and SSL.
Okay.
So
with Kafka?
Yeah.
Right, okay.
My only question is, like, I think if you specify ACL, you will say what permissions does the new Kafka broker will allow to do operations on Zookeeper.
Now, in case of
ACLs.
but even if you have ACLs, right, do you secure your Zookeeper? Because if you secure your Zookeeper, that's a separate entity altogether. In case of Zookeeper, you have the option, and Zookeeper doesn't even support SSL, so you must use Kerberos. Zookeeper doesn't have SSL support as far as I know.
Yeah, but what I figured out is that before starting my Kafka broker, I have to enable all accesses for my broker to Zookeeper.
All access from your broker.
You have the options like read, write, and
You may not have the configuration that I'm talking about. That's the only guess I have, which is in Zookeeper side, you can say, and I don't remember the exact name of the config, but you can say, I only want to look at the user part and not the rest of the part. If you don't have that, then yes, because now you have a new identity. It's not the same identity that all the other brokers are using. But if you have that part enabled, then in that case, you shouldn't have to. And again, I don't think Zookeeper supports SSL, so you must have some JAS section where you are specifying this. Or your Zookeeper is unsecure, which is a bigger problem. Okay? Or I'm wrong, and Zookeeper does support SSL from some version. Okay. Any other questions?
So are the numbers we have there, are they with SSL and SASL, or is just SSL?
Which
The numbers.
the reduction? Yeah, that's just from SSL. SASL itself doesn't matter. The reason it doesn't matter is it's one time. Because only when you are establishing your connection for the first time, that's when we are doing the SASL exchange. once you are done, it's a long living connection, and over the period, the amortized cost, SASL wouldn't really matter. So SASL is, not anywhere going to affect your throughput or latency. Okay, any other questions? Oh, yeah. Go ahead.
You mentioned about Kafka Ranger.
Right.
So what is that all about? Is it like a Kafka manager, or is it only with security? What is it?
Ranger is a separate project altogether. Really nothing to do with.
Is it open source?
It's open source. It's called Apache Ranger.
Okay.
They keep changing their name, so I don't know what's the latest name, but it's still Ranger, right? Okay, right. So Apache Ranger is the name. That is a product which allows you to kind of integrate with all these different Hadoop ecosystem things. So you run Ranger. Ranger has a database that is backed by, and Ranger then becomes your ACL management and auditing portal. So once you say, hey Ranger, here is the information about my Kafka cluster. Here are all the brokers, and here is Zookeeper, all that. Then Ranger has a way to say, okay, I'll go and get all the topics, and I'll allow you to, in my UI, define ACLs, all that. And it's not just Kafka. You can say, here is my HDFS, and it'll do the same for HDFS. You also have to go to HDFS and configure my authorizer from this point onwards is not going to be the HDFS default authorizer, but Ranger's class. And all Hadoop ecosystems generally have this thing as pluggable, so that because Hortonworks has Ranger, they are backing that, I think, and Cloudera has Sentry, and they are Apache Sentry. Is that the name? I think, yeah, Apache Sentry. It's only for security. It's only for authorization and auditing, as far as I know, and I know little about these things, but these are portals where you basically integrate with other secure Hadoop ecosystem products. It gives you a nice UI so you can define your ACLs, and it gives you a nice UI so you can go and audit things. Like they have good performance on auditing as well, which most internal systems don't really do a good job at. It's all in the log file, it's not really in UI, it's not really searchable, whereas these guys have solved that problem for you. Yeah, you had a question. Oh, you think? Right. We haven't yet, and I think primary reason we haven't is that's a problem for which you don't necessarily need a server-side support.
Well, I was just more thinking about not the authentication part, but maybe the authorization.
Yeah, the authorizer part. So we haven't seen that. Even honestly, getting the host in there was also very difficult, because everybody's like, why do you need host in there? Most systems don't do it. So having one more dimension would definitely not have been accepted. The second thing is, in this case, you don't really need server-side support. What you could do is, let's say you want to allow, user A is only allowed to read from topic B from time A to time B.
Just wondering if you have seen such.
No, I haven't, but if you want to do it, you could do it even right now, right? You could just make a call, write a cron job which adds that ACL to allow him at 1 o'clock, and then another cron which removes the access at 2 ACL, 2 o'clock, right? So you could do it outside of server-side support, which is why I think even if someone has the use case, they haven't come up to us. They have just done it the way they want to do it. Any other questions? Yeah. Right. So Kerberos sucks. That's the first lesson one. Meaning, Kerberos sucks for people who have to set it up and who have to actually integrate, read or write libraries that actually does something with Kerberos. But that's number one thing. So we made a joke. Our internal joke is, in my next job, the only question I'm going to ask is, do you run anything on Kerberos? If yes, I'm not interviewing. So but that's not very useful to you. Overall, performance point of view, it's not really going to affect you. So that was originally our bigger concern was, oh, it's going to be a huge issue. But if you're going to, the only place where it will become a huge issue is if you use SASL for encryption. So right now we are providing SSL for encryption. There is also SASL for encryption, and in general, if you enable that, you're basically doomed. You're not going to get performance that you're not even going to get half the performance that you expect from Kafka. That's what we learned, and that's why we have basically disabled it. We didn't even publish it to open source. It's not something that's recommended, even if you are going to do your own implementation. So that's one thing that was kind of something that other people told us, and we still went ahead and implemented, I think, and we learned that, oh, no, they were right. So let's just drop the support altogether. Otherwise, it was more of a developers learning, like, oh, authorizer, do you really want to do host, or do you really want to? So it was more of a discussion thing. Right now, if you're on a Hortonworks or Cloudera or any other distribution, setting it up is also just clicking buttons. So you would not see the complexity behind the scene. Like all the configs that we are mentioning, you probably don't care. You just say enable security, done. So for you guys, all that probably wouldn't matter. But if you're doing it behind the scene, it's still really a big pain in the butt. Like you have to go, you miss one config, and there is really no good way for us to tell you what went wrong. Like ideally, in most systems, what you would see is if a user makes a mistake, I tell you, hey, email the missing@.com something. Here, I don't have a way to even tell you that your key tab, and that's just Kerberos. No matter what happens, Kerberos just gives you one exception, unknown host, KRB5, XYZ. So I don't have a way to tell you what is the mistake that you're making. So that, again, it all comes down to Kerberos sucks as far as we are concerned. So if you don't need security, don't push it on yourself. That's generally my advice. Like in Netflix, I don't think we run secure clusters right now. So if you don't need it, if you have other ways that you trust, like, oh, I have very good firewall and I have good ASG and security group configured, I don't need it, don't use it. And we developed the feature, and I'm still telling you, if you don't need it, don't use it. It's very hard to configure it right, and it's very hard to debug it once it's configured if something goes wrong. Okay. Anything else? Okay, I think we can stop the recording and go back to networking.